Every second, the world creates a staggering amount of digital data, photos, videos, messages, and records, flowing across the globe like invisible rivers of information. To store all this, we rely on massive server farms, endless rows of machines working day and night, consuming enormous amounts of energy and space. But these systems have limits. Hard drives fail, cloud servers crash, and sometimes precious data is lost forever. The warning signs are everywhere. As our digital footprint grows, we need a new solution, one that's smaller, more durable, and far more efficient. Enter DNA, nature's own storage device. DNA, the molecule that stores all the instructions for life, is now being used by scientists to store digital information, ones and zeros, inside its spiral structure. Imagine streams of binary code, those familiar 0s and 1s, floating across the screen, ready to be transformed into something extraordinary. Scientists convert these digital codes into the 4 letters of DNA, A, T, G, and C, each representing a different piece of information. These letters are arranged in precise sequences, forming a code that can store entire libraries of information in a single drop. In high-tech labs, researchers use advanced tools to write and read digital data in DNA, pushing the boundaries of what's possible. Machines sequence DNA, decoding the information with colorful readouts and streams of data flowing across their screens. Think of a giant library, filled with books and knowledge. Now imagine shrinking all that information into something the size of a sugar cube. With DNA storage, entire archives can be condensed into tiny, glowing cubes, making the impossible possible. This tiny object pulses with the power to hold centuries of human knowledge, safe from time and decay. Of course, DNA storage isn't perfect yet. It's expensive, slow, and not ready for your home computer. But the technology is advancing fast. It's not ready to replace your SSD just yet, but the future of storage is closer than you think. Smaller, smarter, and inspired by life itself. DNA strands glow and multiply, forming a luminous bridge to tomorrow's world of limitless information. Imagine sleek archives filled with glowing DNA cubes, storing the world's memories in a space smaller than ever before. Traditional data centers may soon give way to compact, glowing DNA storage units, ushering in a new era for humanity's digital legacy. Imagine a future where entire archives of human knowledge are stored in sleek, minimalist vaults, each glowing cube representing vast amounts of information encoded in DNA. These futuristic archives are compact, efficient, and beautiful, redefining what a data center can be. Inside these translucent cubes, swirling strands of DNA pulse with light, each one holding the secrets of civilizations, scientific breakthroughs, and the stories of humanity. The storage potential is almost limitless. With DNA storage, the knowledge of the world could be preserved for thousands of years, safe from technological obsolescence and natural disasters. Just a few strands can hold entire libraries, ensuring our legacy endures. Picture a split screen. On one side, massive, power-hungry data centers, on the other, tiny DNA storage units that fit in the palm of your hand. The difference in scale and efficiency is staggering. As DNA replaces traditional servers, energy consumption drops dramatically. Animated graphics show power meters falling, symbolizing a greener, more sustainable future for data storage. Imagine a world where DNA storage facilities blend seamlessly into green landscapes, supporting both technology and nature. The environmental impact is minimal, and the benefits are immense. Dive into the molecular level, where intricate structures of DNA encode digital information with astonishing precision. This is the new frontier of data science, where biology and technology merge. Watch as streams of digital information flow through DNA strands like rivers of light, moving effortlessly and securely through the building blocks of life itself. DNA strands multiply and expand, hinting at the incredible scalability of this technology. As our data needs grow, so too can our DNA-based archives, without the massive footprint of today's data centers. Abstract visuals show biological DNA merging with digital technology, symbolizing the dawn of a new era where information and life are intertwined. A burst of light marks the breakthrough moment, the union of biology and technology, opening doors to possibilities we are only beginning to imagine. In this vision, a single perfect DNA strand rotates slowly against a cosmic backdrop, representing the infinite potential of DNA as the ultimate storage medium. As the DNA strand turns, a bold title appears. The future of data is in our genes. The journey has just begun. The DNA pulses with a final brilliant glow, then fades to black. reminding us that the next chapter in data storage is already being written deep within the code of life.